Welcome everyone to the 6th Tensorflow Js Show and Tell. We've got several new demos for you today, and not one, but two book giveaways. The first is a signed copy of the latest Tensorflow Js book by O'Reilly, and for the second, we've got a few copies of a brand new book around data science in JavaScript by Pact, teaching you all about Danfo.js, which is essentially pandas in JavaScript. So if you want a chance to win one of those, ask questions throughout the live stream to our wonderful presenters, send your love in the live chat, and of course join our hangout after the show where we'll be selecting the winners. Now I see many familiar names in the live chat, so welcome back to the regulars. It's great to see you here, and thank you so much for being part of our community here on the TensorFlow channel. And for those joining for the first time, smash those subscribe and like buttons so you don't miss future sessions. Now it's not too late to invite a friend. The number of people using TensorFlow JS has grown exponentially since 2020 when we started the show, and we'd like to see more folk getting to know each other on these live streams, as it's a great way to take your first steps and find someone to hack with. In fact, if you've got a project idea you could use TensorFlow JS for, let us know in the comments below so people can help you out. Now I'm seeing more projects than ever coming out using the Made with TFJS hashtag, and often all it takes is a spark of inspiration to enable people to take their first steps. Now for those of you new to the show, I'm Jason Mays, Developer Relations Engineer for TensorFlow JS here at Google, and remember this is a live stream, so feel free to ask me questions in the live chat and I'll try and get through as many as I can. Now, our audience today comes again from a diverse set of backgrounds. Some might be new to TensorFlow JS, some might be experts in machine learning, and some might even be new to both. There's something for everyone, no matter what your background, so fear not, but for those of you who are new, here's a very quick recap on what we're about to see. Now, TensorFlow JS is an open source machine learning library, just like the Python version some of you might already be using, but written in JavaScript. Now what this means is that in a single click, you can perform machine learning in the web browser and beyond, essentially anywhere JavaScript can run, which is basically everywhere. That means on the client side, on device, server side via Node.js, native apps, and even IoT devices. Now if you're running in the browser, you don't need to set up any complex environment for others to try your model out. You can run on device, even offline with lower latency, as there's no server-side calls after the first page load. And many of the models you know and love are being ported to run in this way to get even more eyes on these machine learning models that are coming out from research for real-world use cases. So if you're a researcher tuning in right now, consider porting your model to the web as a way to get even more eyes on your amazing work and of course get feedback on your model's performance too. Now on the subject of amazing work, today we've got 6 new demos built by folk in the TensorFlow JS community from all over the world. And it should be noted that many of the presenters are live with us here in the YouTube chat too, so do feel free to ask questions as you watch the show or just cheer them on in the live chat. We love to see those emojis. Now links of demos and further reading will be in the description of the YouTube video after this show, so check those out to learn more and to try the demos for yourself. Also, to keep in line with tradition, for those of you who want to continue to nerd out, we'll have a smaller Google Hangout at the end of the show that's not broadcast live to meet fellow community members and to ask any questions you might have about TensorFlow JS in a non-recorded setting. Maybe you've got a project idea and you're looking for someone to hack with, come join us afterwards to discuss, and of course for a chance to win those books that we spoke about earlier. Okay, so with that, let's get the show started and meet our first presenter. So now we're joined by a very special guest, Rich, who has created some of the finest work I've seen using our pose and face models to create a whole bunch of interesting web experiments from music generation to virtual avatars. So to kick things off, Rich, who are you?
Hi, Jason. Thanks for having me on the show. I'm Rich, a designer, creative technologist, web developer, and as you can probably tell, I'm a huge fan of VTubers, which is why I'm currently in this form. But yeah, I'm happy to share a bunch of my projects that I've been working on.
Awesome. So maybe you can tell us more about the demos you've made for us today and why you made them.
Yeah, so today we have 2 projects that I've been working on over the past year or so. One is a web theremin called Theramix. It was made in celebration of the 100th anniversary of the Theremin, which is one of the earliest electronic instruments. And two, and I mean, you're pretty much looking at it right now. I've been working on a lot of VTuber web apps that allow you to do real-time motion capture directly in the browser.
Wow, that is very, very impressive stuff. I've got a lot of questions to ask about all of that stuff I've just seen. Let's start with the Theremin, just to kind of go into a bit more detail on how that's actually working. I see you're using two hands there. Can you explain a bit more about how they're controlling the sound of the music?
Yeah, a theremin kind of works by controlling volume and pitch. So the left antenna that you see, that controls volume. So as your hand gets near it, the volume gets louder. On the right side, that's the pitch antenna. So as you get closer to it, it's a higher pitch.
And then I also saw in the second iteration of this, where the character comes into play as well, the kind of interaction slightly changes here. So what's happening in this scene?
Yeah, so taking inspiration from this just being a very simplistic instrument, essentially all that your hands are doing is controlling sort of X and Y coordinates on a graph. You know, with that note, I'm modifying specific values based on those X and Y coordinates. This is a pre-rendered MIDI file of Next Color Planet by another VTuber. And so what I'm doing here is I'm adjusting the synth's quality, the timbre, the sound of the instrument to sound different, adjusting the attack, the delay, the decay, and so forth.
Very cool. So you can customize what it is you're varying in different situations, which is very nice as well. Cool. So moving on to the avatars, or VTubers as you call them, I must say I'm impressed with how lifelike they actually look and behave when you're interacting with the screen there. And maybe you can talk a bit more about how you are controlling these, the different kinds of models involved in doing that as well.
Yeah, and just to give a background, like typically in the VTuber world, there's around two types of models that people would like to stream from. One is a 2D format called Live 2D, which is essentially what I'm using right now. It's sort of a 2.5D sort of animation. And the other one is sort of full 3D tracking. Traditionally in the past, you would have sort of actually mocap suits.
Right.
But more recently nowadays, people have just been streaming with limited tracking and just have, some slight easing here and there to give the illusion that there is, more movement, more depth for sure.
Yeah. Oh, interesting. So the main advantage of the 3D version over the 2D is the ability to kind of move the character's hands kind of with more perspective in the Z-axis, if you will, and kind of get more variation on that side of things.
Yeah, definitely. It's definitely a lot more dynamic, being able to sort of interact with an audience using your hands. The downside is that, at least in the current space, there isn't quite a safety net for these types of 3D avatars. So you can get some pretty scary results when joints don't move in the right way. But yeah.
Yes. Mm-hmm. Sure. So it's still experimental, I guess. But I mean, from what we've seen today, it's working pretty well from what I can tell. And of course, there might be some edge cases there to iron out over time. But considering you're doing this with just a regular webcam and the TensorFlow JS models and also the MediaPipe models, that's still very impressive stuff to be able to do that with just such limited hardware resources as well. So amazing job there.
Yeah, thank you. Thank you.
Okay, so focusing on the face tracking part of this for just a second, can you provide some more details about what's going on there?
Yeah, for sure. So let's just take this unique opportunity to just zoom in on my face. But yeah, so kind of what's happening here is, I have to somehow derive blinking, sort of eye close, eye open from, let's say, 0 to 1 from a cloud of points that are given back by the face landmarks detection model. And so what I'm doing here is I'm kind of just setting an arbitrary point or segment between 2 points on the face, and then kind of comparing it to others. So with regards to the eye blink, there's basically an eye ratio calculator. So how much is open, how much is closed, and then there's definitely a threshold where you might want to blink or wink or sort of blink because the model is actually not as accurate, and if you have each eyelid operate independently, the eyes won't open and close at the same time. So that's kind of weird there. And it's the same trick for the mouth as well. Just sort of comparing ratios. For the mouth, I'm actually using distances between the eyes and distances within the mouth key points as well, just to give it a little bit.
Oh, so the eyes are actually helping to drive the mouth movement. That's interesting.
Yeah. That the eyes sort of give it a sort of baseline to sort of ground it at, like what is one, and sort of like how to be able to then compare it to it. Yeah,
do things. Yeah, okay, that's cool. And yeah, just looking at this right now, like the mouth accuracy there looks very on par of when you're talking and the amount of your talking and this kind of stuff. It looks surprisingly accurate, actually. That's really, really exciting to see. The other thing I wanted to ask as well is that you got a variety of characters there. So I guess using your system, people can import their own models, and then it would work with the kind of rigging you've got set up already.
I kind of like purposely built these projects. These projects actually kind of started first from the renderer to see if the models that people typically use, Live2D for 2D capture, VRM for 3D models, if that renderer exists on the web, because that's definitely a place that is not commonly supported. It's something that's more commonly supported in like Unity SDKs and stuff like that. The story for KaleidoFace with the 2D capture, I was actually not really working with, but I was in close contact with just a single developer that was making unofficial sort of plugin library to actually render that on the web easily. Okay. But luckily, the 3D models do have official support from the sort of model makers, the people who sort of own that sort of standard, that 3D model standard, and they've been maintaining the 3D library, which does include Three.js.
Sure, very good. And my final question around this area, I guess, is when you were creating this and deploying to the web with TensorFlow JS, what were your biggest challenges in actually making this work? Were there any kind of edge cases that were particularly difficult?
Yeah, I guess probably the biggest, and it's still an ongoing issue, is definitely performance and noise. A lot of times the noise isn't quite filtered out, and even though there is confidence levels for each key point, it can vary quite drastically and might not even work. So there is actually heavy easing on a lot of, especially the 3D capture, but even on the 2D capture as well.
Okay, good to know. And yeah, hopefully this will improve with time, of course. And we've got a number of models coming out in this space. I believe we've just released a MoveNet model, which might be suitable for your 2D capture maybe in the future, which has a lot of less jitter in the predictions of the key points. And maybe that could be useful at some point for the project as well. So yes, something to continue investigating and researching into, of course. Wonderful. So I'm also curious about what your plans are for the future. How do you see these evolving, or do you have any new ideas you want to create?
I guess for the near future, and it might already be in a sort of good space for open source, but what I plan on doing is sort of taking the calculation portion of my app and sort of just making a sort of concise library that kind of wraps everything else. And, I think the greatest limitation with apps like this is actually in the renderer. So like, if we can kind of decouple it from there and then maybe plug in this type of, pose capture into other models, other platforms, I think there could be a lot of potential there. So I'm excited about eventually releasing that.
Excellent. That sounds very good. I look forward to seeing that coming out.
I'm also interested in sort of moving a bit away from the pose capture space and maybe exploring some more generative AI models. There's this one, I think it might be Gans, but I'm not too sure. But there's this sort of one model that this cool, also VTuber enthusiast has been exploring. But he's actually created a model where you can input a single image and it actually spits out frames that correspond to these types of animations. So all you would need is a single image and you can pretty much have a full animation. And I think that could be really
like a webcam image of myself, and then it'd be transformed into the character in a GAN-like style. Is that what you're getting at?
Not quite like that.
Okay.
You would still need the art to be sort of in a particular style because that's how it was trained.
Okay, yeah.
But this type of animation is actually pretty laborious. You would actually need to separate out each layer. So the hair and everything that moves is a separate layer that is transformed within that program. But, being able to sort of take out that friction of creating a model, which is another barrier of entry to VTubing, is definitely a super interesting space to be in. And, it's only going to get easier from here.
Well, do tag us when you make something in that space if you manage to figure that one out. I'm sure everyone will be interested to see how that turns out.
Yeah. And thanks for having me on.
No problems. One final thing before we end here is I'm sure people want to know how to try this for themselves. How can they actually do this for themselves?
Yeah, I mean, all the demos are web demos. So, feel free to click the links in the description and, go wild with the Theremin or, try out this version of KaleidoFace or the 3D version. They're all fun.
Excellent. Sounds good. So do check out the description and the link after the show, or add a comment to the video as well. And with that, thank you very much for being on the show, Rich.
Thank you.
Thanks, Rich, for that amazing interview. I do believe that's the first time we've had a VTuber live on the show. Very exciting times. Now, for those watching, how could you use a system like this for an idea that you have? Do let us know in the comments. Now, if you've got any questions for the presenters, feel free to type in the live chat whilst we're here during the rest of the show, or send some emojis to show your love. But now it's time for me to move on to our next presenter. Okay, so today we're joined by Javier from how9.ai, who's created, how9.ai, which is a service enabling data science in JavaScript powered by Tensorflow Js. Welcome to the show. And first up, please tell us a bit more about who you are and your prior experience with machine learning.
For sure. Thanks, Jason. And obviously, thanks for having me. And yeah, I'm basically been a software engineer for 15 years. And in one way or another one, I've been working on either data analysis tools or big data tools, and more recently, AI tools. So definitely very happy to be here and being part of this show.
Data science in JavaScript, that's a really cool thing. What inspired you to make this? Maybe you can tell us a bit more about your end goal here as well.
Yeah, for sure. So, there was like a philosophical goal in some ways. And, I feel very passionate of making artificial intelligence more accessible to more people. I really feel that that can close the wealth inequality gap and bring more people into tech, and why not? And then more in a short term, kind of like note, I found out that web developers, a lot of them want to do artificial intelligence, but the tools are not there yet. So it was kind of like an easy startup point for us to focus first on web developers and just make the community and the tools a little bit better. Yeah.
Great. And a lot of our viewers might actually be coming from other backgrounds as well. I'm sure we've got some people from the Python world also watching. How does this compare to, say, existing tooling in Python for data science?
Yeah, I mean, obviously, we all know that Python is probably one of the best programming languages to do artificial intelligence. But I feel like there's a lot of opportunity on JavaScript as an AI tool for deployment, right? So, it actually happens to be quite hard to run Python on a mobile device or on the browser. And kind of like JavaScript allows you to build applications either for mobile on something like React Native or directly in the browser, and actually simplify your server infrastructure by not having a server or increasing performance and privacy. So even though like Python is considered like a pretty great programming language for AI, I do feel like there's a lot of niche areas where JavaScript really shines.
Yeah, definitely these days with people having products in the web world, you can then integrate with those a lot easier then too, which is awesome. So yeah, that's great. So I think it's about time for a demo to see what you can do.
Yeah, for sure. All right, yeah, so in this particular case, I want to show you like data analysis that we're doing in HAL9 starting from scratch. So the first thing that we're doing is we're gonna start from a CSV file. And this particular CSV file has all the posts from the Wall Street Bets Reddit group. And nice. There's a lot of talk of GME and AMC and why not. And it's first of all, you can see that the tool allows you to very easily drag and drop blocks to construct what we call a pipeline. And basically a pipeline is a data analysis pipeline that we use to import the data, right? That's the first step. So, we can take a quick look and we see that there's 52,000 rows, it's a lot for a data visualization. So to keep things simple, we can also filter this particular data set, right? So we're gonna say, don't show me all the records, just show me the top most upvoted titles in this data set. And that way we can reduce the size to 2,000 and 2,000 and something rows. And now we can kind of like, okay, let's take a look and see if we can build a little visualization, right? Just to get a sense of how the data looks like. We have a bunch of different visualizations, but like one of the common ones is the scatter plot, which is literally just dots over a matrix of X and Y coordinates. But still pretty useful because it can show us that there seems to be two groups of posts here, right? One of them with very little comments and the other ones with average comments, but they have the same amount of upvotes. So you can probably imagine that one of these data sets is probably a lot of memes and a lot of like GIFs where there's not a lot of comments, but it has more votes, and why not?
Yeah, I love how easy it is to kind of drag and drop things into the flow there and then get the instant visualization of that all in action. That's super, super cool.
Yeah, we're really trying to make it super easy for web developers to not have any fears of data science. So we also believe that the blocks really help you kind of like cross that barrier pretty smoothly. Yeah.
You can focus on the data, which is
for sure.
Very useful.
Yep. And then, what we're doing now is we want to see kind of like how the GameStop stock compares with other types of posts. So we're just asking on the title, we're just scraping the title to say, if the title contains the words GME, call it, a GME type of post, otherwise call it other, right? And that should help us, kind of like build our visualization to see if we see some patterns on, different types of, behavior between different posts. And here what you can see is that honestly, both of them look pretty similar. Like you see this pattern where, there's posts with a lot of comments and the other ones with medium comments. So nothing super interesting. But now we can start looking at, using Tensorflow Js to actually figure out more interesting bits and pieces on this data set. So we're going to drag the sentiment block. And basically the sentiment block uses a TensorFlow pre-trained model from the TensorFlow GitHub repo that basically analyzes if each post is positive or negative, right? So, we can do that just by drag and dropping, but really what is happening behind the scenes is TensorFlow is, categorizing what type of post it is. And those are the sentiment scores that come directly from TensorFlow. So, like all the magic is done by TensorFlow. And that score tells you basically 0 is something very negative, probably some profanity involved as well. And then 1 would be something very positive, right? And then we can basically use that data to do another scatter plot. And then here we're starting to see some interesting things. Like it almost looks like a little, like U-shaped graph, where there's a lot of upvotes for things that are very negative and lots of upvotes for things that are very positive, right? So we all know that social media tends to get polarized. So maybe this is not that surprising, but definitely with TensorFlow you can figure these things out.
Yeah, so this is very interesting to see. By applying the sentiment analysis using TensorFlow JS, we can now kind of pull out these kind of outliers, if you will, on the two edges there, which, as you said, is a link to the kind of polarizing opinions on social media of very negative and very positive extremes there. And it's very visually seen in that.
And then the last thing that we can do is we can drag the number of comments to the size of the bubble, right? And this is actually showing something interesting, that it's a bit different from the rest of the stocks that are being talked in Wall Street Bets, right? So the orange one are the other ones. And you can see that there's a lot of comments, like the bubbles are bigger for the posts that are positive. Not so much for the negative ones, but for the GME ones, for whatever reason, which I don't know why, but there seem to be also a lot of engagement from the community on negative titles, right? So maybe the community is trying to defend the stock, or maybe they get passionate about it. Yeah. But there's definitely quite a significant difference on the type of number of comments that go in relation with negative posts. So that I find interesting. And honestly, this is the way that you do data science. You play with the data, you explore it, you use tools like TensorFlow to actually try to figure out what the data is telling you.
Totally, yeah. And it's good to be able to, have that playfulness when looking at data. Often, many of us are used to command line interfaces and getting the standard deviations and the means and all this kind of stuff for the various columns and all that kind of thing going on there. But this really brings it to life a lot more and might spark other ideas in your mind as you see it visually represented like this in real time. I think that's very powerful.
Yeah, for sure. And lastly, but not least, I think one of the most interesting features that we have on HAL9 that is really enabled by TensorFlow JS is that you also have access to the entire code behind each of the blocks. So, as you can see, you can modify the opacity of this particular chart and, customize it to whatever degree you want. Or you can go back to the previous sentiment analysis block. And actually here we're scrolling and looking at the TensorFlow JS code, right? So, you can see how we loaded the model, how we are transforming the text to actually push it into the model. And then you finally see TensorFlow JS scoring the model. And this is something that, it's first of all, it's a great learning tool because, it gets you to do things without code. But secondly, you can also learn and modify it to your heart's content.
Yeah, that's great. And so this tool is clearly really easy to use, and I love how you also expose the raw code that's being generated behind the scenes so that can be tweaked by anyone, more advanced users, for example. So there's something for everyone there, no matter what skill level you're at there. If you're more on the coding side, you can get down into the weeds. And if you're more higher level, then you can just play around with these high level features as well. I was wondering on this, is there an upper limit onto how much data you can actually import into the system?
Yeah, I mean, well, definitely, with a big enough machine, right, it shouldn't be an issue, right? But
sure.
Definitely, we've been working with, 10,000, 50,000 rows on JavaScript. But recently we started investigating this tool and library called Arquero.js. So by default, JavaScript works with data in a row format. But Arquero.js actually supports a columnar, structure of the data. And we've been able to do data analysis with up to 1 million rows on Arquero with no problem, which is actually kind of interesting. So one of the new features that we're planning to integrate is convert all our blocks to use Arquero to let users use bigger data sets. But, in general, this is something that we're very passionate about, trying to push the boundaries of how much data you can process with JavaScript in combination with TensorFlow JS. So definitely we're looking forward to connect to the community. If you want to contribute, self-promotion, we have a GitHub repo with our code available where, developers listening to this, episode can join us and contribute and, propose fixes, open issues, and definitely make this more of a community effort than what we're currently doing. Yeah.
Wonderful. That's really great to hear. And yes, on that note, I've also seen other things like Danfo.js also being produced from the community as well. So there's definitely an interest in replicating some of this tooling we've seen in Python in JavaScript. So hopefully all of this will grow together and make some very powerful systems in the future.
Yeah, we're definitely also super excited about Danfo.js. It definitely, it's another project that the community could help out. We definitely, are a bit understaffed, but we're waiting for the opportunity to also contribute to Danfo.js.
Really cool. So what type of models do you actually support at present in the how9.ai system?
Yeah, for sure. So let me show you some of them, Jason. Definitely, we have some of them, and we're looking forward to work with even more together with the community. But for instance, we have one example of Bitcoin price prediction. It doesn't really matter whether you're using Bitcoin or not, but what is really interesting is that you can use an LSTM model, which stands for long short-term memory, which is one of the bespoke models for doing actual time series analysis. So here what we're doing is we're actually doing the training. It's a TensorFlow, code that, it's all based on TensorFlow JS, obviously, and it helps you train that particular model. So that's one of the cases, which is probably one of our most advanced models.
Yeah, I think that's very useful as well, because time series data is often very common in real world situations. So I think this could be very interesting for our users too.
Yeah, no, for sure. So we have those type of models. Then we can also do some image processing. So for instance, we can do image classification by, with MobileNet. So for instance, what you're looking at here is we have different images. For instance, in this case, it looks like a cat, even though it's being recognized as a cheetah, which I think it's a fair suggestion. But yeah, so you can also use MobileNet and take a look at, the TensorFlow JS code that kind of like powers this. And you can very easily, connect to different types of sources of images and classify them. Mm-hmm. And, you can also do more simpler stuff, but I think it's as interesting. You can also do things like, figure out how the temperature are changing over time in our planet and do some regression models. So for instance, in this particular case, we have a simple exponential regression. You can choose from, say, linear or logarithmic or power or why not. And then you can project kind of like temperatures into the future and, to whatever degree you want. Yeah. And again, what is really interesting is if we take a look at the TensorFlow code, all we have to do is, for instance, in this case, give the equation to TensorFlow, which is mx plus b, which is, the intercept. And then basically, that TensorFlow does all the magic to actually optimize the equation and find you a model that fits. And it's doing all that in real time, right? So you can see how, it's feeding the data, and it's doing it through gradient descent, which, I'm sure some people on your channel are aware of. And again, like all the heavy lifting is being done by TensorFlow, but you get to do data analysis in the browser in a very easy to do way.
That's interesting.
Yeah.
So in this situation, you can actually define any equation or try and fit the best values for the parameters of that equation for the data that you're presenting to it, which is
for sure. I mean,
useful.
and it's the simplicity of TensorFlow makes it such that you can define your own equation, and honestly, TensorFlow doesn't care about the complexity, and tools like gradient descent are pretty great at dealing with very complex models. So you can expand also this pretty easily if some of the listeners have a keen eye for mathematics, for sure.
Sure. Yeah. Something for everyone.
Yeah, I know. Yeah.
Amazing. So now if people want to try this out for themselves, how can they do so?
Yeah. So hoping that you can take a look at the how9.ai webpage. Basically, there you have access to the tool, which is completely free after you log in. And you can also scroll all the way down to our social media links, and you can get in contact with us in GitHub, in Twitter. We even have a TikTok account where we're trying to make data visualizations fun. So definitely, if you're into that, we're looking forward to connect with you in whichever social media platform you're at.
Excellent. So do go connect with them, everyone. And remember, if you've got questions, you can add a comment down below as well. So with that, thank you for being on the show, and I'm super excited to see this area grow.
Thank you so much, Jason, and see you soon.
Wow, really exciting stuff there. Data science in JavaScript. It's really great to see companies being formed like How9 that are making data science and machine learning more accessible to everyone. And dare I say in the future, maybe more fully featured and useful than what we have had before in this industry. Now, if you know someone who could use a tool like this, feel free to share today's show with them. Now remember, if you've got questions, ask them right now in the live chat whilst we head on to the next demo. So today I'm joined by Sean, who's been exploring using TensorFlow JS with geographical information systems. Now more on that in just a moment, but first, Sean, tell us more about your background and who you are.
Thank you. I'm Sean Mcgee. I've been a developer at Esri UK for over 5 years. Esri create ArcGIS, which is leading GIS software. And as Jason said, GIS stands for Geographic Information Systems. Fundamentally, that just means really advanced maps and mapping. I started Esri UK as a developer advocate, where I dabbled with machine learning for proof of concept applications. And for the last 2.5 years, I've been a consultant helping Esri UK customers solve real world problems with GIS and more recently, GIS and machine learning.
So I hear you've been working on some interesting demos. What exactly have you made?
Recently, I've been exploring using TensorFlow JS with imagery. So imagery is, if you think about looking at a map and you see it's almost like a photo draped across the world. So that's satellite imagery. So we've been looking at using satellite as well as drone and UAV imagery to recognize objects. Fundamentally, if we look at the TensorFlow JS sample website, we've got the webcam sample where you can show an object and it can show back what that is. You can do the same techniques with imagery in GIS.
Okay, that sounds pretty cool. So applying that same technology to your satellite imagery to do some fun things.
Yeah, absolutely.
Excellent. Well, I like the real world use cases here, so maybe we can see it in action.
Yep, sure thing. So when I select on these cars, it shows the image of the car at the top right, and it will show the label underneath saying cars with a little icon of a car as well. And then underneath that, we've just got meters. I'm toggling that with my keyboard just to bring back the size of the object. So now if I select this ship, it will bring back that it's a boat with just a simple click. It's really quite performant as well. And I'm just going to zoom over to the port here and notice that it brings back boat at port. So with the model that we trained, we're not only able to recognize what the image is, we can bring back what a potential object is doing, or almost like more metadata rather than just saying this is a thing. With this final boat that I'll select on, note that the green circle is the radius in meters, and then there's a black dotted box that represents the extent that we bring back. But I just wanted to quickly go into the console if that's okay, just to show you what's happening behind the scenes. So when I select on an object, it brings back the probability. So this is bringing back the probability of this boat. I'm going to go over and quickly show you what that looks like with the car. So if I then select on the car, we can see it's got a 97% probability that object is a specific car.
That works really well, actually. And I like, this has a lot of potential. And I like how we can apply this to, obviously we're looking at some satellite imagery right there and then, but of course you could get the computer to actually kind of scale that out and go, show me all the boats in port across a 10-kilometer radius or something like this. Yeah. And of course, you could have that counted for you automatically rather than manually having to go through this data, or all these other things become possible once you are able to recognize things like this, right?
Yeah, absolutely. And one of the things that we can do is, if we think of imagery, that's just RGB data. It's pixels, like a photo. Yeah. But a lot of these, like drones and satellites, bring back more than just RGB values. So
interesting.
If we stick for the boat example, if we've got bathymetry data, that's like elevation, sea information. And a colleague recently run a deep learning model and created a model that could look for shipwrecks. So it can scan a massive area where a human couldn't manually check and just run a model to determine where the shipwrecks are.
Wow,
cool.
That's pretty cool. So why did you use TensorFlow JS for this project?
So we found that we ultimately wanted something to give instant feedback. And the specific customer we had in mind didn't want to have the whole overhead of hosting a whole Python script in the cloud somewhere alongside this application. And they also had a model that was potentially always getting smarter.
Okay, cool.
The problem was if we were to run that against a whole data set, batch processing, then we'd have to do that quite frequently. So it's almost we wanted live instant feedback in the browser.
I see. Very cool. So a great matching right there.
Absolutely, yes.
So yeah, this clearly has a lot of potential. I'm curious to hear maybe what other areas this might go in the future. Do you have any thoughts on that?
Yeah, I think there's so much potential with this. There's obviously the potential of running this sort of technology against RGB and imagery that we've discussed. Then we could almost do a hybrid of imagine using accessing CCTV camera imagery to determine, let's say, crowd control, which would be really helpful from a security perspective. And the GIS aspect, if you've got a whole map of CCTV cameras, you'd be able to work out where there's potential danger. That's just an example of what that can potentially do. And then a similar thing could be applied for, if a car park's busy, you could just look at the imagery and it could be saying it on a map that say it's busy without a human having to manually do something.
That makes sense.
Yeah.
Very cool. And I've always been wondering about how real-time the satellite imagery can be. Can you actually get semi-real-time streams of a certain region that you could then analyze, or is that more of you need to send a satellite up into space just for you to do that?
So that's a good question. So you can do some near real-time imagery techniques. What I was particularly mentioning there was more like the static CCTV cameras that obviously have a live feed that are in a certain position. But that does lead me to a similar technique of imagine cars with cameras on. So in England, we've got a lot of vehicles from the council, like bin trucks that have cameras already built on. If we did something like detect potholes, then
nice.
using GPS, we can set it back up and saying, here's a pothole, just with
that's cool.
some image recognition.
So give me analyzing the road as you go kind of thing, and give valuable data back to people who need to maintain these things, of course. So that's
absolutely cool. Yeah, definitely.
So can people try this out for themselves? Where do they go?
Yes. So I've created a GitHub repository with all of the code that I've used for this. At the moment, I've left the image service URL blank. So if someone's got an image service URL they want to put in, then they can. But I've also given notes to the ability to use the world imagery service is what I'm using inside the demo. But as a quick licensing thing, you need a developer subscription to access the export data, just as a quick note. But yeah, it's all available on GitHub.
Perfect. Well, we'll put those links in the description after the show, so do go check those out. And of course, if you've got any questions for Sean, you can write them in the comments below the video as well. Now, with that, thank you so much for being on the show. It's great to see this project, and I'm very curious to see where it ends up.
Perfect. Thank you very much. Thank you.
Thank you so much, Sean, for that creative prototype. I really love how these ideas can start off simple by reusing a pre-made model, but then with a bit of love can turn into something very powerful like this use case for analyzing vast amounts of satellite imagery on the client side. In fact, a question to everyone tuned in right now: how would you use one of our pre-made models in your current business or line of work? Let us know in the comments below. And with that, let's see who's up next. Okay, so next up we've got Doug, who's been exploring autoencoders and Tensorflow JS. First though, Doug, tell us more about your background.
Hi, so I'm Doug Duhame. I'm a software engineer here at Yale University, and I also teach classes with the Statistics and Data Science department. And my work revolves mainly around combining machine learning and WebGL to create demonstrator projects and to help sort of educate students on some of the inner workings of machine learning. So we have an example project here, Pixplot, which allows users to take a custom collection of images, process those images, and then project them down to this 2D sort of space and explore the collection so that similar images are positioned proximate to one another in this space. And as you zoom through the space, you can see all of the women in dresses, for instance, over here. And then, we also create projects to help students sort of envision some of the mechanics of machine learning. So we have another example project, UMAP Zoo, which we can see here. And in this project, what we're doing is we're taking 3D OBJ files, which are, sort of like game assets, and we're projecting those from 3D down into 2D so that you can immediately visualize and intuit the mechanics behind dimensionality reduction, which is one of the sort of building blocks of machine learning.
I love how you can see how those are warped into different dimensions there. It's really interesting to see.
I love that seahorse.
Yeah. Great stuff. So what exactly is an autoencoder, and why did you decide to make one in TensorFlow JS?
So an autoencoder can be sort of understood as two distinct neural networks that work together to complete one larger task. So we have an example of an autoencoder here where if we look at just the left side of this sort of diagram, where we move from the first layer to the second layer to the third layer, we can see that the number of units that are being used to represent this input are gradually shrinking. So our inputs in this case are images. And we can see that the number of sort of neurons in each layer is steadily decreasing until we reach that middlemost layer. And that middlemost layer comprises a sort of latent space, is the way people talk about it. That contains a compressed representation of that input data, whereas the input might have 1,000 units, 1,000 sort of neurons required to represent it. Then in our middlemost layer, we have just 2 neurons representing that input.
That's very interesting. So I think some questions from the users might be here. Is this just a multi-layered perceptron, or is this something different to that? It looks very similar to a multi-layered perceptron.
Well, if we were just looking at sort of the left-hand side of the autoencoder, what we just examined, where we're shrinking down the number of units in each layer, maybe there are some similarities to a sort of perceptron-based network. But the important thing about the autoencoder is that it also includes that right-hand side, where we learn how to expand that latent space, that shrinked dimensional representation of inputs, back to their original sort of data shape. So working together, the first half of the network, the encoder, which shrinks data down, and the second half of the network, the decoder, which blows those shrinked representations back up, they allow us to sort of compose this latent space in which we can sort of navigate and sample and see what different positions in that latent space look like when we expand them back out to the full data size.
So you mentioned something called latent space. What exactly is that?
So the latent space is the representation of our data once it passes through the encoder. The first half of that autoencoder neural network, the encoder, again, learns how to create reduced dimensional representations of our inputs. If we look at this space here displayed on the screen, we have a sort of 2D Cartesian coordinate system, just like in high school geometry, x-axis, y-axis. And each of our images, which is just a single digit, is represented in a particular XY offset in this coordinate space. And you can see as you sort of click into a particular region of this coordinate space, if we ask for the full size representation of the data that's contained at that region of the latent space, we can see sort of how that position in the latent space gets expanded out to a full-sized observation, a full-sized image in this case. So as we click through different sort of positions in the latent space, we get different output images. And this allows us to create sort of latent space walks, or to see what different kinds of outputs look like as we move through this latent space.
So essentially the features it's learned from the input images are encoded in those dimensions, which we can then walk across to kind of see other variants in that particular dimension that you're going in, essentially. Is that kind of what this is?
Exactly. Yep.
Yeah.
All the way down
cool.
to 2D. Yep.
Okay, perfect. Excellent. So why did you decide to make an autoencoder in the first place?
So this work was part of the sort of initial research behind a project called Beyond Imitation on the Yale University campus. And this project brought together some particle physicists with the Digital Humanities Lab on campus. And what we were trying to do is to generate new dance sequences using machine learning. Yeah, so we went into a motion capture studio, had some dancers dance around, and cameras in the motion capture studio capture the positions of these different vertices on these suits the dancers wear. And then we pass that data captured by those cameras into different machine learning algorithms, including an autoencoder, in order to generate new dance sequences. And so,
Wow. Mm-hmm.
yeah, the autoencoder was our first model. We moved on to some generative adversarial networks and other sort of generative algorithms thereafter.
This sounds very interesting. Maybe we can switch to other demos to see how this works in action then.
We have a demo here where we're sampling not digits, the MNIST data, but a different data set, the Celeb A data set, which is a really great data set of celebrity faces that have been curated and sort of cropped to the same shape, to the same image size. And if we train an autoencoder on the Celeb A data set, then we can compose that latent space, and then we can sort of create one of these latent space walks where we're moving gradually through the space, and we're asking the decoder part of the autoencoder to expand, this particular XY offset of the latent space to a full-size image. And as we move through the space, we can see that the faces gradually sort of morph from one kind of face into another.
That's super cool. And like the output here is like almost like a dream-like effect, which is really, really nice. I like that a lot. I'm sure some of our creative folk could have a lot of fun with this one. I guess some people might be wondering, what's the difference between this and say a GAN? Obviously, GANs also produce images like this of faces and things like that. I noticed this was a bit more on the fuzzy side. Is that a feature of an autoencoder, or what is happening there?
It's more of a bug of the
Okay.
minimalism of this example of an autoencoder. This project was made as a sort of demonstrator project to show how can we make autoencoders, how can we use them in TensorFlow JS, and it was meant more as a pedagogical resource. That said, you could use larger inputs and train a larger autoencoder to make your outputs less fuzzy. But to get back to the original question, the difference between autoencoders and GANs, generally the chief difference is that these are very different, neural network architectures. An autoencoder is composed of the encoder and the decoder, which want to learn to shrink the data down to a smaller dimensionality and then blow it back up, respectively. Whereas a GAN is, similarly comprised of two distinct neural networks, a generator, which wants to generate lots of outputs, images in this case, and a discriminator, which wants to learn to differentiate between output images that are sort of genuine, that were part of the training data, and those that were not, that seem to be incorrect or dodgy for some reason.
So would it be a fair assumption to say that a GAN is more useful when you're trying to generate synthetic data that is like a certain thing, whereas the autoencoder is trying to almost memorize the original data set to reproduce it? Is that kind of a good way to look about it?
Absolutely, in broad strokes. Yeah. Though, it should be said that these two architectures are not irreconcilable. People are experimenting with, sort of hybrid models. Yes. And there's a really great book, GANs in Action, out of Manning Press, for readers or listeners who want to experiment with GANs and want to sort of graduate from autoencoders to GANs. That book will take you through that full progression.
Sounds like a fun read. Definitely check that out, everyone who's watching. So TensorFlow JS doesn't have an official pre-made model for an autoencoder. So how exactly can someone make one with TensorFlow JS?
So one sort of cheat code is to create an autoencoder in TensorFlow and Encoders, and then just export its weights and import them in TensorFlow JS. And so if we want to go that route, which is a nice simple route for beginners, we can compose an autoencoder just as you see here, with a minimal sequence of Python lines, where we're going to articulate an encoder. You can see that as a sort of class attribute there, and a decoder, also a class attribute. And then we're going to stack those into a model that's part of this autoencoder class. And so in just a few lines of Python, we can create our autoencoder just like this. And here we can see how we can train that autoencoder. Just a few more lines, and we'll pass in that Celeb A data set that we downloaded earlier into our model, and let those encoder and decoder sort of subnetworks learn their respective tasks.
Excellent. And then, of course, I'm guessing using the command line converter to then transfer over to JS land.
Precisely. Yep. And there's we can see that command right here.
Cool. Looks good. Now, I have to ask, how can people try this for themselves?
Well, I've taken the liberty of writing up a little blog post that attempts to help users, step through the sequence of operations needed to download the data, write the network, train the network, convert that network to Tensorflow Js ready inputs, and then finally create the web viewer that allows one to sort of explore the latent space and do, one of these latent space walks. So feel free to check out the blog post and let me know if it's useful and if you get to make something fun with it.
Excellent. So yes, do check that out. We'll put the links in the description after the show. And of course, if people do make something, let us know in the comments below or reach out. I'd love to see how else people would use this to use autoencoders in their own work. And maybe we'll see some of those results in future shows. And with that, thank you so much today for joining us, Doug. Nice to see you.
Thanks very much. It's been a blast.
Wow, I loved how those almost dreamlike faces were being generated in real time right in the browser. I'm pretty sure someone watching right now could use that in a creative piece or artistic installation. And of course, if you've not seen Doug's full write-up on how he made this, it's a must read. We'll put the links in the description after the show. Now, if you've got questions about what you just saw, do leave a message, and remember, if you're enjoying the show so far, hit that subscribe button to be notified of future shows. We do this every 3 months. Now onward to go to our next presenter. Okay, so today we've got Francisco, who's applied some of our TensorFlow JS models to the world of sports. First though, as always, tell us some more about who you are and your background with machine learning.
Sure. Hi, Jason. Thanks for having me first. I'm Francisco, the CEO of Team Sports, AI sports performance platform. I'm based in London, you probably can tell by my accent. And my experience with TensorFlow and machine learning goes back 2.5 years ago or so, starting with YOLO initially, and then settling with TensorFlow to deploy our sports platform.
Awesome, that sounds really cool. And what exactly is it that you've made?
Sure. I'm an avid athlete and a basketball player myself. And what we created was a sports platform that helped teams, amateur teams such as myself, to access sports performance data and statistics easily and affordably. So we created a platform that enables both coaches and players to use artificial intelligence and TensorFlow models to generate the performance statistics they need to understand why are they winning games or not winning games, and how can they improve their performance, whether it's from a conditioning or from a skills perspective. And that is, in a nutshell, is Team Sports.
Very cool. That sounds very useful. So I believe it's time for a demo. Can you walk us through it?
Sure. Cool. So what you're seeing over here is a library of exercises. So any coach has the ability to access Team Sports platform, upload their videos, configure the videos to cater for the needs of their players. So the level, the number of reps, and some of the standard configurations for an exercise. In this case here is a conditioning exercise, and they can simply upload the video and publish to the web. But the clever part here is what you're seeing is our editor that enables us to detect performance stats, in this case reps. You can see the girl doing the lunges over there, and you can see nothing is happening, it's not being counted. But we created an algorithm that sits on top of TensorFlow models that enables us to say, hold on, what are we tracking over here? What limbs are important for this exercise? And how can we create a sequence of positions that then enable us to track? And so what you're going to see here is me defining how do I want to track one of the legs. In this case, it's the right leg. So I'm adding the leg in 2 separate positions. And what this will enable us to do is to understand what the exercise or what the girl is doing with the leg.
You can pause the video basically any way you wish to kind of capture that moment as a keyframe, if you will.
Exactly. And, I think this is the most of the basics examples, but you can take this to any level. You could track a completely new, this is only for SEALs sort of exercise where you can come up with all sorts of combinations of aspects that you want to track, or a combination of movements or sequence that you want to track. And it becomes a very powerful tool. And this is available to everyone, and to any coach. Any amateur coach could come here and create a custom exercise, or use or leverage their existing exercise. They don't need to create a custom one, but it's as easy as you've seen over here. And now, with a few clicks, we can track the movements of both legs, and there is a performance stat. You can publish that exercise, and as simple as that.
I love how easy you've made it to actually capture the key points and add data to the system. So I guess if you have a video where there might be slight variations to the pose, you can add like multiple examples of the key points.
So I think there's two layers here. So what we're doing is sort of using the MoveNet. We started actually with PoseNet initially, and we talked a little bit about that. But with MoveNet, effectively what we're doing is sort of, okay, now that we can track a human body, what can we understand of this movement? So we wanted to create an algorithm that was slightly independent from the machine learning. So we're not training a model to detect push-ups and squats, or a basketball drill for that matter. And that enables us to not rely so much on AI, because remember, we're deploying this into a mobile app with limited resources, and not everyone has a Google Pixel 6, which is not out yet, so no one would have that. But no one might not have the latest phone, and therefore, because of the limited resource on the phone, we want to limit the number of models that are currently running. And is our algorithm on top of it, and sort of as simple as you saw, our position editor, that enables us to say, okay, so what sort of movements are happening here, and what we know of this movement. And now that we can create a configuration of the movements that we're trying to track, let's count them. And that creates the reps, and that creates the 1 push-up, 2 push-ups, 3 push-ups.
So it will allow for some variation, but if my leg's in a slightly different kind of angle or something like this. Okay, cool.
Indeed. So you probably have noticed that it's also, so we've got some tolerances. So it's not just, the tolerance will enable us also to deploy exercises for youth. So if you get a 12-year-old to try to do a good squat, they're probably not going to be in the right form. And that enables us to say, actually, this is for kids. Let's add a little bit more tolerances. Or this is for a semi-pro. Let's reduce the tolerance because they should know how to do this stuff, that sort of thing. Sure.
Yeah, okay, that sounds good. Now, you mentioned you're using MoveNet there, which is our latest pose estimation model. Indeed. How easy was that to actually integrate into your product?
Once you get around of sort of the new abstraction layer and then sort of the API, that sort of effectively decouple the model from the rest, I think was fairly easy. It took us 3 to 4 days to get it up and running. So and I really like the beauty that now with this abstraction, so we can replace MoveNet with any other model and not having to touch our code, and that is beautiful. That's how it should be done.
So that sounds really cool. So what did this experience look like for the end user?
We created a very simple experience for our users. So whether you're a basketball player, a football player, you can simply prop your phone anywhere on a small tripod or even against the wall. The phone will detect you and the exercise will start. And that's it. The magic will happen. We'll count your performance stats, how many reps you're doing, whether they are push-ups or a ball control exercise. At the end of it, you get a lovely stats. You can see your dashboard, your performance. You can filter and see what you've done in the past. Also, you can see what our teammates are doing, because it's good to see what everyone else is doing. But the experience for the user, it is very simple, and it feels more like magic and less like AI.
And I've also got to ask at this point, I guess, what would be on your wish list of other types of models that you might want to explore in the future? Maybe some of our viewers might actually be able to help bring those to life for sharing in the community in TensorFlow JS. Any thoughts?
My wish list is so long, Jason. I'm not sure we've got enough time. But I guess there's two sides of it. So being able to track multi-pose, so more than one person. If you think in the world of sports, you're doing a drill, you're probably doing a drill with someone else. So being able to capture two separate people, that would be fantastic. We have a use case tomorrow for that model. But beyond that, we'll also be able to track things like a ball. So a lot of the exercise and drills, will be using a ball. So a ball control exercise, for example, it is about, how you control and is the ball in your hands or not. So being able to track, sports balls. So let's not exclude American football balls, which are not round, or rugby balls, which are not round. But being able to track the ball or any other sports equipment, maybe a weightlifting, a dumbbell, or etc. Those will be fantastic. So we could deploy that in the next couple of days, and it will be our users will be loving to use that. Yeah.
Excellent. Well, I've got some good news for you there and for our viewers, actually. Our MoveNet model will actually be supporting multi-pose very, very soon. So look out for that update coming. And I'm sure some people from our community will be able to make some kind of ball detection model using some kind of multi-box detection. I think one of our community members, Hugo, actually made a great tutorial on how to do multi-box detection for custom objects. So if anyone wants to give that a go and share it with Francisco, that could be a fun side project for someone. So good stuff.
Awesome.
All right. So for any of you watching, if you think you can help Francisco out, do reach out or drop a comment in the message box below. And on the subject of reaching out, how can people try this for themselves?
It's very simple. We've got a website. It's teamsports.pro, sports with a Z. We've got an Android and iOS app. They're out there. Please download the apps and try it yourselves. We love feedback, whether it's within the app feedback, direct feedback, any feedback. We give us some feedback, and do use our apps. They're available to you to use. And we've got some cool features just out, Jason, if you allow me to. Which is, if you download the app now, you can challenge your teammates. So I could do some push-ups and challenge you, Jason, and then you get a lovely notification, and then you have to take the challenge. I get a medal, or you get a medal. So
okay, very good for these times where we're all at home.
Exactly.
A good chance to challenge your friends
Exactly,
and see who wins. And I think most people watching will beat me. So, but thank you very much for being on the show today. It's great to hear from you.
Thank you for having me. Thank you. Bye.
Thanks to Francisco for that amazing real-world use case. Now, on previous episodes, we've seen how the community have used older models like PoseNet for yoga, but Francisco has managed to create a really nice generalizable user interface for any sport or fitness application, which uses our latest MoveNet model. Now, that's something worth thinking about. How can you create a system that can be used for multiple things around a given industry? It might just lead to your next business idea, so get thinking and find someone to hack with. Now, on that note, if you're using PoseNet, please upgrade to use MoveNet, which is much faster and more accurate and will achieve much better results. In fact, I just mentioned in the chat there, on my PC with a 1070 GPU, I can get 120 frames per second out of it. Now, we've got a unified pose API allowing you to swap between 3 different pose models in an easy manner, and you can check that out after the show if you wish on the Tensorflow JS website. Now, remember, our presenters are live in the chat with us here today, so do ask questions if you have any, and now we'll head on to our next demo. Cool. Is what it is.
Technology and JavaScript in particular, and this is amazing how you can actually do so many things with JavaScript besides the browser. For example, in IoT, in robots, and in machine learning as well, just to name a few technologies where JavaScript is applicable. And there is a saying like, always bet on JavaScript, and I cannot agree more.
That's awesome. So it's great to have you with us today. But what inspired you to make this?
I was and I still interested in the self-driving car topic, and I found that Udacity have the self-driving car course. In that time, I was thinking, okay, and could we do this in JavaScript using Tensorflow JS? And
here it is.
Here it is. It works. Yeah. We could. The answer is we could.
That sounds very awesome. And I think Okay, so we had a slight audio glitch there. We're going to restart this interview to make sure it's perfect. So let's go and do that right now. So I'd like to welcome Alex to the show, who's used machine learning to drive a virtual car in a 3D game, all powered by a custom TensorFlow JS model. Now, before we learn more about that, Alex, tell us a bit more about who you are and what's your prior experience with machine learning.
Hi, Jason. Thanks for having me on your show. I'm a software engineer here in Moscow, Russia, working mostly in enterprise accounting automation. But besides of that, I'm eager to learn new things about the technology. Actually, my favorite topic is web technology and JavaScript in particular. And this is amazing how you can actually do so many things with JavaScript besides the browser. For example, in IoT, in robots, and in machine learning as well, just to name a few technologies where JavaScript is applicable. And there is a saying like always bet on JavaScript, and I cannot agree more.
That's awesome. So it's great to have you with us today. But what inspired you to make this?
I was and I still interested in the self-driving car topic, and I found that Udacity have the self-driving car course. In that time, I was thinking, okay, and could we do this in JavaScript using Tensorflow JS? And
here it is.
Here it is. It works. Yep. We could. The answer is we could.
That sounds very awesome. And I think clearly everyone watching right now wants to see this in action. So maybe do you have a demo for us that you could show?
Yes, of course. And let's go straight to the final model, which drives the car. So you could see here on the left side, we have the Udacity simulator, and we open it in the mode when we could send the commands to the car. And we, on the right side in the terminal, we start the driving script, which uses the model we have built to drive a car. And you can see it drives. It knows only two commands, only to turn left or turn right. It actually sends the angles, and we can see the steering angle. And the positive value is turn right, and the negative value is turn left. And the car pretty much drives pretty well on that track.
Cool. So essentially then you trained this by grabbing a lot of frames from this 3D engine. I'm guessing you're driving the car initially and then dumping these frames to disk somewhere. And then you're using that to train some kind of vision model to allow it to know what your rotation for the steering wheel was in that moment of time. And then, of course, you train the model and then see what happens with the results, right? Is that basically the flow that you did there?
Yes, you got it right. The basic flow is like this, and Simulator, it provides great tooling for that. It works basically in two modes. The one is the training mode, when you drive yourself the car in this environment. And it records 3 images of the front camera, of the left camera and the right camera, the view on the road. And for each image, it also records the steering value, the throttling value, and I think braking value. But in that project, we are using only the steering value. And the interesting thing here is that you have to drive really carefully, because the car, like a kid, would learn from you, from your style of driving. And actually, this is called the behavioral cloning. That style of machine learning, of car, or self-driving car learning.
And which model was it that you're using to make this work?
I used my proper model, which took me a bit of time to figure out. I experimented what is the least size of the model. Could I use less convolutional layers?
I see.
Could I
more
use,
efficient.
yeah. So more efficient, because to train it really quickly and to get the results. Yeah. And in the video, what we was watching a minute ago, actually that driving is able after just one epoch of training.
Okay, wow,
model.
That's very impressive.
So and the training on my machine, that's a couple of minutes, and I have MacBook Air actually, and on the powerful machine with a GPU, I think it's less than a minute.
Okay,
it could drive, and I think almost that was like a central idea of this project I built, is to show that first we could use JavaScript for drive a self-driving car. We could use JavaScript for machine learning. And all of that with really few lines of code. It's, I think, no more than 3 screens of code, including like helper functions.
And that's in the JavaScript language, or did you start in Python and convert to JavaScript?
Actually, yes. I experimented first with Python to find the better model architecture.
Oh,
How
I see.
many
Okay.
layers? How many layers to use, and do I have to use max pooling? What the size of these layers? Do I use the how many dense layers? All that stuff.
Yeah.
All that stuff.
Yeah.
And then I implemented everything in JavaScript, and the model itself, it's trained actually using Tensorflow.js in JavaScript. There is no any conversion. Because if I experimented on my machine with JavaScript with no video engine,
Right, you needed the remote machine to kind of tinker around.
That would be more complicated.
So this demo clearly works really, really well. And I'm curious, what paths did you take or did you try to get to this point so it worked as well as it does?
The most of the challenges was to understand how the simulator works and to create an efficient and a small model to use in that project. First, I dig deeper in the simulator. It's open sourced, so I found what commands I have to send to the car, what are the numbers which are in the output. Another big challenge is to figure out the efficient model, to find how many layers do I have in that particular model. How many connections and all that stuff. The first models, they obviously didn't work well because I created, for example, a very deep structured model, deep network, and I could not like train it properly in the small amount of time. So we have to figure out what works well, what works not, and I think this is like what machine learning like engineers do, and they tinker with different architectures, with different models, and trying to find the best way to
works best
to make it work. Yeah.
Cool. And how did your car handle different game environments? Maybe does it work well on all different levels, or do you need the custom training data for each?
Yes, and this is the really good question. Thanks for this one. In the simulator, they provide 2 environments, and for the model we are seeing was trained using only one of the environments, and the second one the model have never seen. And if we start, but we could actually enter in this environment and start the driving script. And we could see that it goes off the track to the accident almost immediately. It remembers only the track it's in. We could go here in 2 ways from there. We could either train another model on this different track in a different environment. It's a question, would it be enough the model for the first track I created with 2 convolutional layer, one max, which is following each by one max pooling layer. Would it be enough for the second one, or the second one is more complicated? Thus, we will need a complicated model, and this model is not enough for that track. And I think the pinnacle of all that should be the thing to do a model which could behave well on both tracks. And
yes.
I think this is the real self-driving car, which could drive itself no matter what environment it's in.
Yeah, so a lot more training data required there, I'm sure, for training that model. But with enough, I'm sure you'd get there. So good stuff. So if people want to try this out for themselves, how can they do so? Is there a website or some GitHub code available?
Yes, sure. There is a GitHub repository with the project, and it also have a README file which describes how to use it, and it also have a link to Udacity simulator. So one have to clone this project, install our dependencies, including Tensorflow.js, and also install the Udacity simulator.
Sure.
And you're all
And it
set. You
works.
could record.
Okay.
It should work. I would like to encourage people to experiment further and experiment and give some like framework, some tooling, some like boilerplate to from which the many possibilities are available.
Okay, that's great. So we'll put those links in the description after the show. And thank you so much for being on the show today.
Thanks, Jason, for inviting me. It was a great pleasure and a great honor to me to participate in that show. And I also would like to thank all the creative people who bring their project to that show. And I find inspiration in that projects. And obviously, thanks to the whole TensorFlow team for maintaining this wonderful library.
Cool, thank you, and see you next time. Amazing work by Alex right there. We finally have self-driving cars in JavaScript. Now, one thing I'd really like to set as a challenge to the community watching right now is to see if we could get this working with, say, a remote-controlled car to drive by itself around an environment of your choosing using TensorFlow JS. You can imagine streaming live camera footage from the car and then using TensorFlow JS models to make steering decisions for you, all running on a local Wi-Fi connection for low latency. Let me know if you manage to make one. Now with that grand finale, thank you everyone and to our amazing presenters. Feel free to share the recording with friends who could not make it today. It's simply the same YouTube link you're on right now. And for those of you still here, we'll be opening up our private hangout shortly for a chance to ask questions and of course to win one of the books by O'Reilly and Pact. Now a reminder that all the links to the demos will be in the description very shortly, and to use the hashtag MadeWithTFJS on Twitter or LinkedIn if you make something cool that uses TensorFlow JS to have a chance to be featured at future events just like this one. Thank you everyone for tuning in today. I hope you're as excited as I am for the future of machine learning in JavaScript, and I shall be seeing you all in 3 months with even more great demos, so look out for the next show. And of course, do subscribe or hit the like button so you don't miss out. And now it's time for our private hangout for those of you who want to meet in a non-recorded setting to nerd out with fellow community members and maybe even the presenters if they're still about. Feel free to join using the link I'm going to put in the chat very shortly. Thanks for watching and see you next time.